Hello everyone. Today we'll discuss the problems on Taylor series. Because of we know that how to substitute the values in the Taylor series, but without using the Taylor series, we can write a series to z is equal to a, means about z is equal to a, or in powers of z minus a. So first example is find the Taylor series expansion of 1 by z square plus z minus 6 about z is equal to minus 1. So first f of z is equal to, actually in the Taylor series we find the f of z derivatives, 3 or 4 derivatives, and substitute in the formula, Taylor series formula. F of z is equal to f of a plus f dash of a into z minus a plus f double dash of a into z minus a whole square by 2 factorial plus so on. In that series we need 3 or 4 derivatives, but here the function is in 1 by z square plus z minus 6 form, means 1 by x form. So if you want to find the derivatives, after two derivatives we are getting to difficult to find the f double dash, f triple dash of z. So that's why we use another procedure to find the Taylor series for this type of problems. So let f of z is equal to 1 by z square plus z minus 6 equal to 1 by z plus 3 into z minus 2. How to write this one? We know how to write a factors to the quadratic equation. So this z square plus z minus 6 write as z square plus 3z minus 2z minus 6 plus 3z minus 2z is plus z, and plus 3 and minus 2 is minus 6. We get the same equation if you write in that form, and common the z, we get z plus 3, and here common the minus 2, we get z plus 3, z plus 3 common, we are getting z plus 3 into z minus 2. So this z square plus z minus 6 write in the factors form. So that's why we can write 1 by z plus 3 into z minus 2. After that we use the partial fractions, then separate the terms. So 1 by z plus 3 into z minus 2 is equal to a by z plus 3 plus b by z minus 2. So take the LCM, and LCM is z plus 3 into z minus 2, a into z minus 2 plus b into z plus 3. Cancel the denominators. We get the equation 1 is equal to a into z minus 2 plus b into z plus 3. Put z is equal to 2, means that easy to solve by using substitutions. So that's why if you take z is equal to 2, this factor completely 0, we can get the p value. So that's why I choose this method. Another method is you can comparing the a coefficients and constants, then find the values. So here substitution is very easy, so that's why choose this method, then easy to get the values. Now first you can put z is equal to 2 in the equation 1. Here 2 minus 2 0, total a term 0. So here 2 plus 3 5, 5b is equal to 1. So b is equal to 1 by 5. Next put z is equal to minus 3, because of you need to 0 b coefficient, so that's why we can substitute z is equal to minus 3. So z is equal to minus 3 in equation 1. We get 1 is equal to a into minus 3 minus 2 plus b into minus 3 plus 3, b into 0. This term completely 0, minus 5a is equal to 1, a is equal to minus 1 by 5. Next, our 1 by z plus 3 into z minus 2, right, as a value is minus 1 by 5. So that's why minus 1 by 5 by z plus 3 plus 1 by 5 by z minus 2 equal to 1 by 5 common. So now you can write first positive term. This term is positive, so that's why 1 by z minus 2 minus 1 by z plus 3. So from a and b, this is the equation b, and this one is equation a. So from a and b we have to write f of z is equal to 1 by 5. 1 by 5 is a common from both the partial fractions, so that's why 1 by 5 into 1 by z minus 2 minus 1 by z plus 3. To write the expansion in Taylor series, about z is equal to -1 or in powers of z plus 1. So how to write Taylor series from these two terms? Here we have a possibility to write z right as z plus 1. How to write it? You can add plus 1 and -1 to the denominator. So here z plus 1 -1, already -2 is there. Minus this one directly you can split 3 as 1 plus 2. So 1 by z plus 1 plus 2. So now our factors becomes to 1 by 5 into 1 by z plus 1 minus 1 minus 2 minus 3 minus 1 by z plus 1 plus 2. So next, we are using the expansions 1 by 1 plus z and 1 by 1 minus z and write the Taylor series. If you want to use the expansions of 1 by 1 plus z and 1 by 1 minus z, constant must be 1. So that's why here we are taking the common is -3. You need to write 1 plus z or 1 minus z. So that's why here common -3. -3 common from the first denominator. We get minus z plus 1 by 3 plus 1, because here we common -3, that's why here we get plus 1 minus. Here it is in the form of z plus 1, so that's why you common only plus 2. Plus 2 common, we get 1 plus z plus 1 by 2. We know that 1 by 1 minus z whole power -1 expansion and 1 plus z whole power -1 expansions. 1 minus z whole power -1 expansion is 1 plus z square plus z cube. 1 plus z whole power -1 expansion is 1 minus z plus z square minus z cube plus so on, if mod z is less than 1. Why we are writing in this form? We need to use the expansions, so that's why we are change the terms in terms of 1 minus z and 1 plus z. So that's why we can take the common 3 and 2. Here -3, here 2. Now we get the form of expansions, that is here 1 by 3 -1 by 3 is constant, 1 by 5 into -1 by 3, 1 minus z plus 1 by 3 whole power -1. And 1 by 5 multiply with each term, so that's why 1 by 5 into 1 by 2 into 1 plus z plus 1 by 2 whole power -1. That is f of z is equal to -1 by 15 into 1 minus z whole power -1 expansion, 1 plus z. In the place of z we have z plus 1 by 3, but it is a expansion for z plus 1. So because of we need to write the Taylor series expansion in powers of z plus 1. So that's why we can write the series for z plus 1 by 3. So 1 plus first term is z plus 1 by 3 plus z plus 1 by 3 whole square plus z plus 1 by 3 whole cube plus so on, minus 1 by 5 into 1 by 2, 1 by 10. So 1 plus z whole power -1 expansion, it is alternative series, 1 minus z plus 1 by 2 plus z plus 1 by 2 whole square minus z plus 1 by 2 whole cube plus so on. It is valid only mod z less than 1. So that's why in the place of z we have two terms, that is modulus of z plus 1 by 3 less than 1 and modulus of z plus 1 by 2 less than 1. This series is valued for these two values only, depending on the radius of the convergence. So next example is obtain the Taylor series to represent the function z square plus 1 by z plus 2 into z plus 3 in the region mod z less than 2. So here the function is f of means f of z by g of z form, or f of z is equal to phi of z by psi of z form. Again, if you want to find the derivatives after first derivative, you are getting difficult to find the derivatives, number of derivatives. And also if you want to change into partial fractions, one more difficulty is there, that is f of z is equal to phi of z by psi of z, but phi of z and psi of z powers are equal. So because of in the numerator z power is 2, denominator z power is also 2. If you multiply these two factors, we are getting the square, z square equation, quadratic equation in z square. So both the powers are equal, then the partial fractions write as 1 plus a by z plus 2 plus b by z plus 3. If both the powers are equal, you can use this form to write the partial fractions. So that's why I am writing f of z is equal to 1 plus a by z plus 2 plus b by z plus 3. And z square plus 1 by z plus 2 into z plus 3, that is equal to LCM is z plus 2 into z plus 3, 1 into z plus 2 z plus 3 plus a into z plus 3 b into z plus 2, and denominator cancel. Now we can use the substitution, that is put z is equal to minus 3. If you substitute minus 3, then first term completely 0, and second term is also minus 3 plus 3 0, plus b into minus 3 plus 2 is minus 1 minus b equal to, you can substitute in the LHS part also, that is minus z square plus 1 minus 3 whole square plus 1 10. So b value is minus 10. Next put z is equal to minus 2. So we can substitute z is equal to minus 2, it is minus 2 whole square plus 1, and the first term becomes 2 0, minus 2 plus 2 term is there, and next one is a into minus 2 plus 3, a into minus 2 plus 3 plus b into minus 2 plus 2 is 0. So that is 4 plus 1 5, a into 1, a is equal to 5. Now we can substitute in f of z is equal to 1 plus 5 by z plus 2 minus, because of a value is 5, b value is minus 10, minus 10 by z plus 3. Therefore, f of z is equal to 1 plus 5 by, so from this you write the function is, means z plus 2 write as 1 plus z form. So 1 plus, if you write a 1 plus z form, you need to common 2 from this term, and also here you can common 3, you can get the 1 plus z form. So that's why in the first denominator 1 plus 5 by 2 common 1 plus z by 2 minus 10 by 3 common 1 plus z by 3. The given region is mod z is less than 2, mod z is less than 2. That should be always, whatever the value is there, that is always the region is convergence. If you need to apply 1 plus z whole power minus 1, 1 plus 1 minus z whole power minus 1 expansions, whatever the z value, means in the place of z, that must be less than 1. So that's why we are writing less than 1. So 2 take into this side, mod z by 2 means modulus of z by 2 less than 1. So if the series is valid for mod z by 2 less than 1, it is also valid for mod z by 3 less than 1. So that's why here this expansion z by 2 expansion, z by 3 expansion, both are valid to the given region. So that's why we can write the expansion for that, 1 plus 5 by 2 into 1 plus z by 2 whole power minus 1 minus 10 by 3 into 1 plus z by 3 whole power minus 1. So that is 1 plus 5 by 2 expansion for 1 plus z whole power minus 1. In the place of z, we have z by 2. So that's why 1 minus z by 2 plus z minus 2 whole square minus z by 2 whole cube plus so on, minus 10 by 3 into, this is also alternative series, 1 plus z by 3 whole power minus 1. 1 minus z by 3 plus z by 3 whole square minus z by 3 whole cube plus so on. This is the required Taylor series for the given region, mod z less than 2 or modulus of z by 2 less than 1. So Now the series right for summation. Sometimes they ask the question prove in the summation form. So that's why I'm writing in the summation form with n values. F of z is equal to, first one is constant 1 plus 5 by 2 summation n is equal to 0 to infinity. First value is 1, no? So that's why I'm taking n is equal to 0 to infinity, and it is alternative series, so that always you can take the alternative sign by substituting minus 1 whole power n, and the term is z by 2 whole power n. First term n is equal to 0, we can get minus 1 power 0 1, and z by 2 power 0 value is also 1. So first term is 1. If you substitute n is equal to 1, we get minus z by 2. N is equal to 2 minus 1 whole square is plus z by 2 whole square. So this expansion right for the summation by using n is equal to 0 to infinity. The second term is also same. N is equal to 0 to infinity. It is alternative series. So that's why minus 1 power n z by 3 whole power n. So here the summation n is equal to 0 to infinity is a common, and minus 1 also, minus 1 power n is also common term. So that's why common these two, and write 5 by 2 power n into 2 power n plus 1 minus 10 by 3 power n into 3 power n plus 1. Z power n is also common right outside. This is the expansion of Taylor series in the summation form. So next sum is very important sum, that is find Taylor series expansion of f of z is equal to 2z cube plus 1 by z square plus z about the point z is equal to 1. Here write the Taylor series in powers of z minus 1. Going to the f of z is equal to 2z cube plus 1 by z square plus z, where f of z is equal to 5 by z by psi by z form, but phi of z power is greater than psi of z power. So generally we can write the partial fractions f of x power is less than g of x, means the function in the form of f of x by g of x, f of x power is less than g of x, then generally we can write the four models to apply the partial fractions. But here these two, above one and this one, special cases to write the partial fractions. Here numerator power is greater than to the denominator power. In this case, we write the partial fractions f of z is equal to quotient plus remainder by divisor. So here dividend is 2z cube plus 1 and divisor is z square plus z. So we are dividing this value with divisor. So first you need to cancel 2z cube. So z square multiply with 2z, then we cancel the 2z cube. So that's why multiply with 2z, we get 2z cube plus z into 2z square, then subtract that is minus we are taking, these two are cancelled, we are getting minus 2z square plus 1. Next you need to cancel minus 2z square, that is minus 2. So multiply with minus 2, we get minus 2z square. So that's why minus 2z square minus 2z, subtract that, change the sign, that is plus plus. So these two values are cancelled, we get 1 plus 2z. So now z is right as 1 plus 2z, means z power is 1. So now we can write the form quotient is 2z minus 2 plus remainder is 1 plus 2z by z square plus z. Why we stop here? The remainder is in powers of 1. So means f of x by g of x or phi of z by psi of z form, denominator power is greater than to the numerator power. So that's why general partial fractions we have to apply. So that's why I stop here, 1 plus 2z and quotient plus remainder by divisor, I write it. 2z minus 2 plus 2z plus 1 by z square plus z. General partial fractions we have to apply for this value, that is we can write this equation consider as a first equation A. After that find the partial fractions to 2z plus 1 by z square plus z. Common z we write z into z plus 1. So partial fractions are A by z plus B by z plus 1. Find the AB values. Now you can substitute it by z is equal to 0, we get the A value is 1, and z is equal to minus 1, we get the B value is also 1. A B value 1, B value 1. General procedure you have to apply for finding the partial fractions, that is put z is equal to 0, B factor completely 0, and A is 0, that is also A into 1, that value is also 1. So now we can write the partial fractions for 2z plus 1 by z into z plus 1, that is 1 by z plus 1 by z plus 1. From equation A, what we have to write? F of z is equal to 2 into z minus 1 plus 1 by z plus 1 by z plus 1. Now write the Taylor series about z is equal to 1 or in powers of z minus 1. So in powers of z minus 1 means how can we write it? Already one term in terms of 2 into z minus 1. Z write as in terms of z minus 1, and here you can add minus 1 and plus 1. How to write z minus 1? We can add minus 1 plus 1 to the z, then directly we can get the series in terms of z minus 1. So that is for z you can add and subtract 1. So that is write z minus 1 plus 1, 1 by 1 plus z minus 1 plus 1 by z minus 1 plus 1 plus 1, it becomes to 2. If you want to write a expansion for 1 plus z whole power minus 1, then here the term in terms of 1 plus z form only. But here it is in z plus 2. So you need to write here constant is 1. So that's why common 2. We get 1 plus z minus 1 by 2. 2 minus 2 into z minus 1. This one is a expansion in the form of 1 plus z whole power minus 1. In the place of z, it is z minus 1. 1 plus z minus 1 whole power minus 1 plus 1 by 2 is constant, 1 plus z minus 2 whole power minus 1. So now you can write the expansion is 1 minus z minus 1 plus z minus 1 whole square minus z minus 1 whole cube plus so on, plus 1 by 2 into 1 minus z minus 1 by 2 plus z minus 1 whole square, z minus 1 by 2 whole square minus z minus 1 by 2 whole cube. So I need to apply the expansions of again 1 plus z whole power minus 1. So in the place of z in the first expansion it is a z minus 1. In the place of z in the second expansion it is z minus 1 by 2. So now I add all the terms and 1 plus here all terms are in powers of z minus 1 only. So that's why I add these two series by common the z minus 1 whole square, z minus 1 whole cube. So first terms are 1 and 1 plus 1 by 2. 1 plus 1 by 2 is 3 by 2. 2 into z minus 1. Don't touch this term. This is as usual. You can write it because of this term is in terms of z minus 1. Plus first two terms. 1 plus 1 by 2 value is 3 by 2 minus from these two z minus 1 common and minus also common. Here remaining is 1. Here remaining is 1 by 2 square. That's why I write 1 plus 1 by 2 square into z minus 1. In the second two terms z minus 1 whole square terms are common. The both are for plus. So that's why 1 plus 1 by z cube. So sorry 1 plus 1 by 2 square. Z here sorry here z minus 1 whole square, here also z minus 1 whole square. You can common z minus 1 whole square, we get 1 plus 1 by 2 cube into z minus 1 whole square. Next one is z minus 1 whole cube common, z minus 1 whole cube and minus also common. We get here 1 here plus 1 by 2 power 4, 1 plus 1 by 2 power 4 into z minus 1 whole cube plus so on. This is the required Taylor series. So you can write the summation 3 by 2 constant, write first 3 by 2 plus 2 into z minus 1 plus summation n is equal to 1 to infinity. I am writing from 1 to infinity because of the series start with z minus 1. So that's why I write with n is equal to 1 to infinity, and starting sign also minus, so that's why minus 1 power n. So 1 plus, here z square is there, here 2 cube is there, so that's why n is greater than to the 2 power, so that's why that is greater value is also 1. So that's why I write 1 plus 1 by 2 power n plus 1 into z minus 1 whole power m. That's all for today.